Not many things in software design get called a law. For most programming decisions, we infamously say, it depends. But not Conway's Law. This applies to every architecture. It says that any organisation that designs a system will produce a design whose structure is a copy of the organisation's communication structure. You can draw the best boxes and arrows that slice up your problem domain brilliantly, but if that doesn't reflect how the developers communicate with each other, you're going to have problems. Let's take a look at some examples. Let's say that all the front-end developers in a company work in the same team and talk to each other daily. They concentrate on enhancing the user experience and grow their understanding of their users together. They agree on the frameworks and the styles that work best for them. And when they read each other's code, they can just talk to each other, which makes it easier to understand the code and interact with it. The code becomes coupled by function calls and also by implicit shared assumptions. You can see how the team most likely creates one cohesive and unified user interface system. Other teams might have requirements too, but won't find it as easy to communicate with the front-end developers as they do with each other. Maybe they have to schedule a meeting or go through the team's manager, or even put written requirements straight into the backlog. Now, imagine the rest of the organisation is sliced by layers in the tech stack, with a back-end team specialising in building server-side logic and a separate team managing the database. Each team naturally builds their own system, and we end up with a layered architecture, a mirror image of the team structure. Each team excels in their respective areas, but they have to collaborate to build features. So when the front-end team want to display some new information, they request that the back-end team make it available via some API endpoint. The back-end team designs something that returns the information in a way that they think makes most sense. And then the same thing happens when the back-end team has requirements for the database team. A layered architecture naturally forms, and the interfaces between the layers has been designed based on the communication that has happened between the teams. Let's take another example where the organisation is split by stages in the product lifecycle. A team of developers, a team of testers, and a team of operations. As a product passes through its lifecycle, it passes between the different teams. Developers write the source code, then the communication is through a well-defined handoff process where they document the expected behaviour and hand over to the testing team who write an automated test suite based on that. The testing team would build a unified test suite with a set of standard testing practices across all tests. They'll refactor the tests according to their knowledge of the whole suite, extracting out common test arrangement or assertions into shared functions. The test suite becomes its own system, with the tests having more knowledge of each other than of the code that they're testing. Later, the operations team manages the release. They'll provision the infrastructure, deploy the software, and build dashboards and alerts based off their understanding of what the software does. Again, this all becomes its own subsystem, and our architecture mirrors the team structure. But what if you organise into cross-functional teams, containing designers, developers, testers, SREs, everyone needed to solve a specific business problem, with each team centred around a business domain? Now the architecture will end up more vertically sliced, with the front-end and back-end concerns of a feature more closely related to each other than to their counterparts in another part of the business. Each slice is owned by one team, who make all of the decisions on how it's built, what the public interface looks like, and, crucially, the model of its domain, and even the words used to describe the objects. This starts to look a lot like the architecture promoted by domain-driven design, splitting the software into subsystems aligned to problem domains, each with their own model and language. When there's a dependency between two domains, the teams need to communicate. Each team only has expertise in their domain, so they'll have to simplify things in conversations with each other by abstracting away some of their domain's complexity. Then the teams design the interface between the systems based on that conversation. And, because the teams are cross-functional, the integration could happen in the front end, back end, wherever the teams agree makes most sense. It's the discussion between the teams that will decide that. So once we recognise that Conway's Law is a thing and our architecture will eventually resemble the communication structures of our organisation, then when we have a desired architecture that we want to get to, we can intentionally shape the organisation in a way that will produce it. This is called the inverse Conway manoeuvre. Now it's the architecture we intend to build that influences how we shape the teams. And if you're practicing domain-driven design and you've identified separate problem domains and designed bounded contexts for your system, this is a great way to build that architecture. Each team can work in their own bounded contexts and develop their own models and language. You can also see how this works well with a microservices architecture, where each team is responsible for building and running their own services and defining their own APIs. You can watch my videos on both of these concepts on my channel here. You can combine all of these ideas together if you like, but remember that Conway's Law exists whether you're doing these other things or not. Keep it in mind when designing your architecture or organising your teams.